nice. Connect your encoder to go live. Okay, cool. Now we're live. Finally. Wow. Okay. Got it. All right. Let's see. Okay. Consider the following regions. Find the volume installed revolving around the specific region around the given line around x equals 0. Oh. So, yeah, this is a vertical one. I can see why this is going to give you, like, trouble.
Yeah.
Yeah. And it's actually, I do it as the last example in my little tutorial thing is... Okay, so let's talk about this. Okay.
Like inverting them?
Yeah, you have to invert the variables is what you have to do. Okay, so we are what the fuck is this line? X to the 9th? Okay. So it's from X to I just want to regraph this, honestly, because I don't like this. Okay. So we're revolving around this. Right, this is X equals 0.
Right.
And then it's this whole area here, which is going all the way. You could use the shell method. I think I'm going to use dude, I hate the shell method.
But we're learning washers right now. I haven't gone to shell yet.
So the only difference between using shells and washers is that the shell method enables you to rewrite the integral in terms of like a different variable. So in this case, because we're revolving around something that's vertical, we're going to have to use dy for our integral, right? We're going to have to do something dy. And that can sometimes get messy. Right. So if you do it in terms of shells, then you can do it in terms of dx. And sometimes the integral is nicer whether you do it in terms of dx or dy. It's just a change of variable. I say it's just a skill issue.
Can you do it doing like using washers and then show me what shell is?
Yeah, I'll show you both. Yeah.
Okay. Cool.
Okay. Because honestly, I hate shells, but we'll do the disk method. Disk and washer is the same thing. It just matters whether there's like a gap, right?
Yeah. The hole.
Which this one does have a hole, right? This is going to be the hole. So as I oh, not that. Sorry. As I revolve this around this, okay, I'm gonna end up getting kind of like a bowl per se, right?
Yeah.
Okay. So first thing you do, let's see if my teaching method makes sense here, is you're gonna write out the integral, which is gonna be integral of pi, and then it's r outer squared minus r inner squared, right? And then it's gonna be like d something, yeah.
Right.
Now, if your axis of revolution is vertical, that means you're going to want to do dy. If your axis of revolution is horizontal, that means you do dx.
Right.
Okay. Next thing you need to do is you need to figure out the bounds. So I need to figure out, in terms of y, what's the lowest y I go to? What's the highest y I go to? And you can see here, right, if this is region 3, this point right here is 1, 1. Right? That's where y equals x intersects with y is equal to x to the 9th. That's got to be that point. Yeah. Okay. So right off the bat, I'm like, cool. All right, this goes from 0 to 1 in terms of y. And now I need expressions for r outer and r inner. Okay. And r outer is measured from the axis of rotation to like the outermost part that's being revolved.
Yeah.
In this case, right, the outermost portion that's being revolved is always this straight line.
I have a quick question as well.
Yeah.
So like, you know how we're revolving around the y-axis right now, right?
Yeah.
But sometimes they add like a bound to the right, like y equals 9 or something, and you have to subtract 9 from the function.
So sometimes what they'll do, I'll get you. So sometimes, for instance, the axis of rotation would be here.
Yeah.
Okay. And so then your distance is this plus this. Okay.
Oh.
In this case, because the axis of rotation is on one of the axes, whatever the value of the function is, whatever, like, for instance, the y value of the function is, whatever the x value of the function is, that's measured from your axis of rotation.
You have to like, remove that.
Yeah. So the one you're talking about is, and actually I have this. This is, where is it? It's this one. Because I do an example of one of these.
It's such a coincidence. That's crazy.
It's trends, baby. It's Google Trends. Like, it knows what's going on. Yeah, where's the one I want? Yeah, let's do this one. Well, no, not this one. Ooh. Where is it? The one was it's like 3 and like 5. Oh, this one. Okay, this is what I want. Here, let me copy this. Can I copy this image in? Actually, I don't even know if I can. 1 second.
Screenshot it.
I could screenshot it. It's just gonna be like low res. 1 second. Let me zoom the fuck in on this. Okay, there we go. Okay. Morning, Eric.
Good job.
Good morning. Good morning, actuators. Actual actuators. Actuators is an engineering thing. Okay, so let's say, for instance, this one, where it's revolving about. Let's do the hard case. It's revolving about the line y equals 15. Okay.
Yeah.
And this is the region. Okay. So in this case, because you're doing a horizontal line, this is going to be the integral with dx. And then in terms of x, you're going to go from 0 to 3, right?
Mm.
Now, let's look at like what r outer and r inner is, okay? So r outer points from here out to here, okay?
Mm-hmm.
And so I want to know what that distance is, all right? So this is r outer, and that's what I'm looking for. Now, I know the total distance from the axis of rotation to the ground, or to the x-axis.
15.
This is 15. Good. Okay. So then how do I describe what this is based on like what value of x we're at, right? Well, when I'm along this function here, which I think this function is 9 minus x squared, okay?
Yeah.
The y coordinate of this function describes this. So for instance, this is y is equal to 9 minus x squared. And if I want to know this, r naught, or r outer, sorry, that's 15 minus this.
So 15 minus 9?
So it would be r naught is equal to 15 minus the function. Yeah, minus 9 minus x squared.
Yeah.
Because it depends, right? Like as you're traveling in x, this value changes, right?
Yeah.
Right?
Okay,
R inner,
you're trying
R
to,
R inner is simple, right? R inner is just equal to 3.
Yeah. You're trying to remove the gap, basically.
Exactly. Yeah. You're trying to figure out what this is in terms of the function. And so the function, right, has like a y distance and it has an x distance.
Mm-hmm.
And that's related to what this is. Y equals 9 minus x squared. This is telling you what the y distance is in terms of x. You could also rewrite this, right? You could say like x is equal to the square root of 9 minus y, right? And that's the x coordinate in terms of y.
How'd you do that so easily? I mean, of course you can do it.
Oh, I just moved this over. I subtracted that, then I square rooted both sides.
Oh, okay, yeah.
Yeah, you're just resolving. And then the hint here is whatever this is, you also need that variable for your r outer or your r inner. So if you have stuff like in terms of y, then you fucked up. Like you need stuff that's just in terms of x because you're integrating with respect to dx.
Right.
Yeah. So yeah, that's the example of. I know this is the last example I put because like this is the tricky one. You have to do. Oh, it's this minus
that bad,
this.
Actually.
It's not that bad. Yeah. Okay.
Yeah.
So in this one, you're kind of fortunate because the axis of rotation is one of the coordinate axes. So when I talk about points along this function, for instance, the x distance of this function is also the distance from the axis of rotation.
Yeah. That was hella smooth. You grabbed that dot and you went exactly on the curve.
Yeah, I was like, I have oh, okay, I got shaky hands.
No.
Okay, so in this case, right, r outer is always going to be equal to 1 because the outermost boundary is always 1. And then r inner needs to describe this distance. This is r inner, all right? Yeah. Which is the x coordinate of this point, right? This is like what I say, like x distances, okay? And you have what was it? Y was equal to x to the 9th. So if I want the x distance, I need to rewrite this equation as x is equal to y to the 1/9.
You just 9th rooted it, or so, like
good. Yeah. I just 9th rooted it. You can also like raise this to the 1/9 power, because a power to a power just multiplies.
Oh.
Yeah. Okay. So our inner is y to the 1/9. And then again, this makes sense because look, do you see how I'm dealing with dy here? I want to make sure all of my r's are just in terms of y's.
Yeah.
Okay. So, final thing is pi integral 0 to 1. R outer is 1, and then minus this squared. So that's y to the 1/9 squared, which is the same thing as y to the 2/9.
2/9, right.
Right, power to a power. Okay. And then it's like this dy. And so this integral is easy to do, right? The integral of 1 dy is just y. So it's pi times y. And then this, right, raise the power by 1, divide by it. So that becomes minus y to the 11th ninths. And then it's times 9 over 11. Uh-oh. 9/11 detected. But I think that's what it is, yeah.
What is that, detection thingy?
You have to add, right, this is adding 9 over 9, which just gets you 11 over 9, but then you divide by the new power, yeah. Yeah.
Okay.
Cool. All right, but then this is evaluated, right, from 0 to 1. Plugging in 0 doesn't do shit, so you just plug in the 1. So you get pi minus 9/11ths. Oh, 1 to the 11/9. Okay, cool, but this is also 1. So it's just, what is that, 11 pi. 11 pi minus 9 over 11. I think that's what that is, yeah. Visualizing this. Ooh, what are we visualizing here? Oh, that's x to the 9th. Ah. Is that, but that's not a revolution though, Narowski, is it? Oh, it's the, oh, did I fuck up? It's the surface of, oh, not the volume. Got you. Yeah. Okay, dude, tomorrow period I have a chem exam, then right after I have math. Oh no. Okay, so that's the disc method, I think. Okay.
I had another question as well.
Yeah.
So like, you know when you have something like e to the how do I forgot what it was. Let me write it. E to the e to like a function, or like or just like any number to a function, like 1 to the like 2x minus 1 or
e
something.
to like whether 2x squared minus 3 or something, yeah.
Yeah, and then you like that is to like squared, like that thing is squared.
Like this?
Yeah.
Okay.
So I saw this thing where like you don't actually square the thing, you multiply by 2. I don't know what that means.
This would be e to the 4x squared minus 6.
Why?
Because so there's a difference between e to the 2x minus 3, all that squared, and then this. This is different. Okay?
That's what I meant, I think.
Oh, okay. Yeah, no, in this case, but this is I don't know, this is usually never written like this. You're right. This would be e to the, what is that, like 4x to the 4th plus 9 minus 12x squared, I think. Yeah.
Oh, wait, I think the first one is like where you multiply by 2, right?
Yes, so this is because e to the a to the b is equal to e to the a times b. Yeah.
No, that makes sense.
I don't think you usually see this one very often. What's up, Narowski? Is it not working getting you on the stage, Narowski? There you go. Now he's on the stage.
No, but my internet went out for a second.
Oh, dude, I thought I gave you like super perms, dude. You're like, you still can't just join?
I still just
the fuck?
I don't know.
I'm about to make you just like mod of admin of the server. Maybe it'll let you then.
It's probably like a certain perm. in this. In,
I
like,
know.
The channel.
There's a weird like stage moderator. I thought I gave it to Narowski, but I'll figure it out. All right. What's up, Narowski? Did you have any comments about this? Am I screwing up somewhere?
No. I just wanted to join because we were
good.
gonna do something afterwards.
Yes, we are gonna do yours afterwards. Yeah. Or I guess Eric's. Ian Stuckey's in the chat. What's up, Eric? Okay. Does this make sense so far, Tuma? Yeah.
Yeah.
Okay.
If you can go over shell, but I guess it's not fair.
I can do it. No, it's fine. I'll do it real quick. It takes 2 seconds. So, shells. So this is like the disk method. Let me do it for shells real quick.
Disk washer, same thing, right?
Disk and washer, the same thing. Yeah, washer. I don't know. I like to say a disk is just a washer where R inner is like 0.
Yeah.
Yeah. Where do I want this? I want this here. Okay, cool. All right.
They should just call it washer.
They should just call it washer. Yeah, I don't know. They get cute and they like call it like 2 different fucking things. Okay. So, all right. The shell method means instead of building a bunch of like disks this way or washers, whatever. Fuck it. Yeah, washers. Instead of building a bunch of washers this way and like adding them up, you build a bunch of like cylinders. Here, I'll show you an example of like one of them. This would be the cylinder.
Like instead of integrating?
You're still going to do the integral, but instead of doing pi r squared, so when you do the washer method, you're taking the area of a washer, pi r squared, and then you're multiplying it up by like dy. And that's how it's a volume, right? Because it's a surface area times a length.
Like a cylinder.
So that's for washers. For the disk method, you're creating a bunch of cylinders. And these things have a surface area of 2 pi r h, right? And then what you're doing is you're expanding these cylinders further and further out. So what you're doing is you're doing 2 pi r h, and then you're multiplying it by like dr, which in this case is like dx. Yeah. So one way is here. Let's see if there's a nice visualization of this. Todd, I hope you know the derivative of e to the x. What? Come on, Todd. Okay. These goofy ass things. Oh man. Can someone just show me like a picture of it, please? Okay. There we go. There we go. Bingo. This is what I wanted. Good job. Right. Okay. So with the disk here. Oh, you're doing Oh, awesome. You're also doing the volume of oddly yeah, everyone's doing this. This is why I have to make this video like this week because everyone's doing it right now. Okay, so when you're doing the disk method or whatever the washer method, you're taking the surface area of this, right, which is pi r squared, and then you're multiplying that by, in this case, dx, because dx is like the thickness of this disk. And then that ends up giving you a volume, okay?
Yeah.
With the shell method, you're starting in the center with like a really skinny cylinder, which has a surface area of 2 pi r h, right? And then you're creating more of those like around it, like it's expanding outwards, like
So it's just the bottom, like
the cylinder's getting like fatter.
But what about the empty space? Is it just gonna keep expanding?
So yeah, so here's what happens, right? So let's say like this would cover, right, this region. To get the next region, this would now be the cylinder. And then just imagine there's like infinitely like smaller ones in between this.
Oh,
Or
I
taller
see.
ones. Yeah. So you're taking the surface area of a cylinder and you're like pumping it up. But as you do that, right, do you notice how the height is changing? Right? You see how the height on this one is less than the height on this one?
Yeah.
Yeah. So
Oh.
your integrand ends up being dy because volume is always a surface area times like a height or like a depth or a thickness. In this case, the surface area was just pi r squared, and then the thickness was like dx, which was like the thickness horizontally. Here, the surface area is 2 pi rh, and then the thickness is dy, because these cylinders are getting bigger and bigger.
So if I'm rotating it about like x, I have to use y.
Yes. Yeah, so it's flipped. Sup,
vice
nerd? Yeah, it's flipped.
Well, what in the heck was that?
That was Chewbacca. Sorry, what else were you saying there?
And like vice versa, like even if you rotate about y, then you do x.
Correct. Yeah.
Oh.
Honestly, this method sucks.
You done messed up, Aaron!
Like, it confuses people. I think people understand this method a lot more, but this method comes in handy if the integral would be easier to do in terms of dy versus dx. That's why they
just
do
the
it.
inverting thing.
It's just a change of variables is all it is. Yeah, and it is the inverting thing. Because sometimes, especially, I don't know, say for instance you have that y is equal to like tangent of x, okay? Inverting this, you get x is equal to like arctan of y. And this is sometimes like not a nice integral to deal with.
Ew.
So, yeah. That's why sometimes you want to like make sure you're doing dx, because this is a much easier integral to deal with than arctangent.
Oh, so I'm getting all the easy problems.
Yeah. I mean, I'm sure they'll throw you an example of like why it's nice to do cylinders. Pour a cat into the cone and measure the volume of the cat.
Surprise, motherfucker!
I guess that works. That's another way to figure out the volume. Pour a cat into the cone? Okay, so in this case, so the integral's a little bit different. So instead of doing dy, we're gonna doing dx because the cylinders are getting thicker and thicker. So this is
So just use
dx.
the original one.
And then it's 2 pi, and then here's what you need. You need r and h, but then these things now need to be in terms of x.
Right.
Okay.
Oh, you gotta switch those.
Yeah. So, so you have to come up with equations for these. So as you're going out in terms of x, right? The height of the cylinder, you see how the height of the cylinder here is this, and then the height of the cylinder is this? The height is just equal to x to the 9th, right? Because it's just the y value of whatever this function was, which is y is equals x to the 9th. Yeah?
So it's just the normal function.
Yeah. This is just x to the 9th. And then the radius, right? The radius of my cylinder, that's just always equal to x. Okay? So radius is now just x. And then my bounds are, right, is that the radius, so as I make like bigger and bigger whatever like cylinders, the radius needs to go out from 0 to 1, right? Because this is the maximum radius it can have.
That looks like a product.
So watch, yeah, it is, right? But do you see how they both have x in them?
Oh.
So this is 2 pi integral from 0 to 1 of x to the 10th dx,
Oh.
right? And this
So
is a
it's
very
always
easy.
1x for the radius.
It might not be. Well, yeah, the radius is usually x. Yeah, I agree. But that can change. Thank you, Taco Cat. I do need to hydrate. That can change though. Because if this axis of rotation is somewhere else, right?
Yeah.
Well, I guess the radius is still x. I'd have to think about that. But I think the height becomes something a little trickier.
It's
in
just
this case-
the function though.
Yeah, it is just the function. We could try doing we'll do that at a later time. But for now, yeah, this comes out to be nice.
Okay.
I think the radius is always x. It might change though. Oh, you know, it would change. No, 100%. Okay, sorry. If you were rotating about this, for instance, now the radius, let's say this is like x equals -2. Now the radius is 2 plus x. Right? Because the x coordinate just like keeps track of like where you are here. But then the radius is from like here to here.
Oh, you're rotating about -2.
Yes. If I was rotating about -2, then the radius would be 2 plus x. Let's say that the region is still this, right?
I thought you're subtracting though to get there.
No. So if this is x equals -2, right? So now let's say the cylinders are about this, right?
Yeah.
Now the radius of this cylinder is equal to whatever the x coordinate is that I'm measuring the height at, plus 2. Right? Because x measures the distance from the y-axis. And if your axis of rotation is off the y-axis, then you need to that's an offset you need to add.
Right.
Okay. So that's when this would become like ugly. This is nice. If your axis of rotation is the x-axis or the y-axis, then yes, for the shell method, r will either be x or y. Pretty easy.
I see. I mean, I guess this, we did the hard part.
So, yeah, and then these, you just integrate this, right? What? So this is x to the 11th over 11th.
Yeah.
And then that's 2 pi.
Yeah.
So what is that? So what? It's just 2 pi x to the 11th over 11. We should get the same answer though. What do we get here? Here I got 11 pi over 11 minus 9 over 11.
It's 2 pi over 11.
Where?
The answer.
The answer is 2 pi over 11? Oh, wait, sorry. And this is from 0 to 1, right? Oh.
Yeah.
So yeah, the answer would just be 2 pi over 11.
Yeah.
Okay. But then, wait, this one was wrong.
No, it was right.
Is this one also 2 pi over 11? No.
No,
right?
no.
Oh, you know why? Because I fucked up. I forgot that the pi goes on both things. The pi has to multiply on both.
Oh,
What's up, Amir?
Yeah.
Yeah. Okay, so this is pi y minus 9 pi y over 11. Oh, okay, so look at that. So that's 2 pi over 11. Same answer.
Wait, yeah. It was right.
Yeah, I just fucked up. I forgot there's a fucking pi on this as well.
Yeah.
Okay, cool. All right, yeah, same answer. Yes. You can see the difference here, right? I feel like the setup is more intuitive here, but the integral was so much easier here. That's the trade-off between like discs, whatever, washers and shells. Is one case you get like hard setup, easy integral. Another one you get like easy setup, hard integral.
Will it always be like that, or do you?
Yeah.
How do
There's
you
always
know
a trade-off.
How do you know when it's better doing one way? Just gotta
You don't?
know.
You just gotta know, I guess. Yeah. I don't know if there's a way to like look at it and say, hey, that's gonna be easier with discs or that's gonna be easier with washers.
Yeah.
I just do everything with washers because I'm an American and we just like brute force the fuck out of shit. So like eventually I know I can do this integral. I may like screw up, but I know once I get to here, there is some way to make this work.
Right.
But it's not elegant, which that's more Naroski's, the European mindset. They would probably prefer this because it's prettier.
Thank you.
Yeah. Okay. Cool. All right. Great. I'm glad that made sense to you. Awesome. Why's my YouTube channel working? Okay. Cool. And ooh, let's see. I want to see if this actually goes into the Discord now. I have too many things open. Sexual education. There we go. We're gonna delete the first one. But here, I'm gonna mark the first one is done. Cool. And then that should show up here. So here's a cool
Have you
thing.
ever
If
done
we could-
circuitry, by the way?
I have done circuits. I do a lot of circuits. I can help you out with circuits too. Yeah. If
No
you want
way.
ever submit a, yeah, I do a lot of EE stuff. Okay, here we go. Thuma, and then look at that. Oh shit, look at that. It has the YouTube and the timestamp. This will be interesting to see. Yeah,
Good job.
this will be interesting to see later once the stream is ended. If you click this, if it'll go exactly to like where in the stream we did this.
You should also add like a what's called like deletion, like when you don't want a problem. Like
Yeah.
right now I said to ignore the first one.
Oh yeah, I deleted it. Yeah, I have a deletion thing on my end. Yeah.
Oh.
So this is only the I deleted the first entry that you put in. Yeah, I can do that on my side.
But you should like let people delete their own entries because they
Oh,
might-
let people delete their own entries. That's interesting.
Yeah.
I then have to come up with like some sort of like user authentication shit though then, right? Because then how do I make sure only you can delete it and you can't like delete other people's?
with the code.
Yeah, you have to like write. You'd have to write more. I'd have to have like usernames and stuff, right? Or I guess tie it to your IP. I guess I could tie it to your IP address.
Yeah, like I don't know. That's kind of dangerous.
It's kind of dangerous. Yeah. Okay, but I think it works. Nice. Okay,
Thank you.
cool. You're very welcome, dude. Look for the YouTube short I put out next week on this topic because it seems to be a hot one.
Yeah.
Yeah.
Yeah, there is also a different method. I just finished
Ooh.
writing it out right now.
What is this? Is this for doing this one? For doing the one we just
Yeah.
did? All right, let me pull it up. Norowski always has like really pretty solutions.
No way.
Yeah.
This
You
isn't
just-
this isn't as elegant. This is more like if you this is more like for like fun stuff, right? So I don't think you'd use this for examples this easy.
Oh, okay. I see. Yeah, let me
Yeah.
see.
Are you
Coolest
just using
dude.
different shapes?
He's doing the centroid. See what this
Yeah.
is.
Because if it's rotation around the y-axis, so x equals 0, then the point of rotation is going to be the centroid of the
Oh, okay.
like the region.
I have to like remember like what a centroid is. Like, is that like the center of mass? Is that what the centroid is?
Yeah,
Or like-
yeah, kind of, yeah.
Oh, I see. So, yes, the centroid is like the averaged like balance point of it, and then if you just do 2 pi r squared times, it's like the average times the whole thing, then you get the whole volume. I
Yeah.
think I kind of get that.
Yeah,
I'm gonna go
that's-
ahead and
that's
like the-
basically the intuitive way of thinking about it. Yeah.
This is cool. This is very elegant. No, I
Yeah,
get it. And this is
yeah.
this is also the
Yeah.
this is the equation right here for center of mass. If you end up doing engineering, this comes up a lot. That's actually pretty beautiful, Norowski, as always. Yeah. But don't worry, Thuma, you don't have to do this in high school. Even though
Because I
Norowski
have
is
to
in
do
high
it.
school. You know,
If I'm like an engineer.
if you get when you get to college and you have to do engineering, this will definitely come up at some point.
I guess now.
Yeah,
it's early.
until then, yeah. If you're doing only rotations around the x or y axes,
Mm-hmm.
this is actually very quick to get the answer. Like if you only care about the answer, this actually gets it pretty quickly.
Dude, if you used what is this called, Pappus's theorem? If you dropped like Pappus's
Yeah.
theorem on this type of class, they'd be like, like where the fuck did you get that from, dude? What?
Wait, how old do you think I am?
Well, the funny thing, Norowski is only like he's in high school. Although I say he's 500 years old because he's a Romanian vampire.
What? This
Yeah.
guy's in high school.
Yeah, he's just really smart. Yeah.
I'm in college, man.
Yeah, it's okay. Everyone learns at their
damn.
own pace. But yeah, that's why you should come by. All y'all watching, you should come by Norowski's stream tomorrow because he's gonna show us his cryptic knowledge he has from centuries of being a mathematician.
This is some bullshit, man. I'm dropping out.
No, it's okay, dude. Norowski lobotomy petition? Oh my god. No. We don't eat the smart people. We like the smart people. They help us become smart guys.
I'm gonna go
Okay.
hit leg day.
All right,
Well,
hit it, dude. I'm gonna do leg day later today. I need to do that. Fuck. Ugh.
Hell yeah.
I always skip leg day, but yes, I'll do it today. Just because you guys.
You have to.
I will. All right. Peace. I'm 40. Don't feel bad. Exactly. Yeah. Knowledge happens at all ages. Sorry, let me catch up on chat real quick. That was really cool. Cool Dude says, "Hey Doc, thank you so much. You saved my tail in an exam last week. Nice. Because one of the YouTube shorts, I just watched it before a test and learned all I need to know. Fuck yeah,
That's dope.
Which YouTube short was it, Coolest Dude? I'm curious." And then he says, do they have a grading system where they split 70% for semester and 30% for a few final tests and projects? Yes. The grading system depends on the class. I would say for most high schools, it's probably like 25, 50. It's probably like 25% homework, 25% quizzes, and like 50% tests. Or maybe they do 25% tests and then like 25% final exam. But I've had some classes, for instance, my quantum mechanics class in grad school was 90% final exam, 10% homework. So like if you fucked up the final, like you failed the class.
Dude, no slurs.
No slurs. What's up, Craig?
What's good, Unc? How was your flight?
My flight? Dude, I flew in like last week, dog.
Okay, but I'm talking to you today, Unc.
Okay, I didn't have a flight today, but yes, my flight was nice. Thank you, appreciate it. Yeah, I flew in on Sunday, I think. Yeah. But I'm here for a long amount of time. Coolest Dude said it was the short on completing the square. No, completing the square is difficult.
No.
Yeah. Wait, you had a question for Narosky. Quick question for Narosky. When did you start to gain an interest in higher math and start accelerating ahead of the coursework? Okay, so yeah, question for you, Narosky. When did you realize you were the GOAT at math, and you were starting to surpass what was currently being taught in your math classes?
So this is like a layered story, right? So in
Okay,
Romania,
layered story. In Romania.
if you want to go to high school, it's obligatory anyway. But if you want to go to high school, you have to take an exam at the end of middle school, which is in 8th grade, right? So it's a cumulative exam of everything you've done from 5th to 8th grade, and it's pretty difficult, right? I could attach it here if you're curious what happened last year. I remember getting like max points in math. You actually take math and Romanian, of course, like English and Romanian, English and math, how it is for you guys. So of course, like I studied math pretty hard and I got like a decent score overall, right? Because you get the average of the two scores, but that's besides the point, right? So I originally didn't like math up until 7th grade. I actually wanted to become a doctor.
Ooh, doctor, lawyer, or engineer, dude. That's the top three, man. But when did it change in 7th grade? What did you watch, like a TV show, or did someone awaken you from your coffin? What happened?
No, I started looking and I found a few videos on YouTube explaining beautiful math stuff that was way above like my pay grade at the moment. And I actually started studying like stuff outside of the curriculum, and I found that it's more interesting if you study alone at your own pace, like what you want to study.
Sure.
Right. So if you don't understand it, like you shouldn't be angry and you shouldn't like throw it away because you can't understand it yet. You should like manage your time such that you don't lack the knowledge you should be getting in school right now, because you're not going to be good at what you're supposed to be doing in the future.
Yes.
If you lack the bases that you're supposed to be learning in like the early grades.
Sure, the foundations.
So, yeah, but you should make time for studying stuff above your pay grade, like struggling, such that when you reach that point, it seems way easier and way more intuitive, right? Even if it's like, oh, I'm pretending to understand this, like at some point it's going to make sense, and it's going to make sense way more if you understand it then.
If you've seen it already, and you're like, it's like fake until you make it.
Yeah, it's like at some point it's going to be like way easier to understand.
Very cool. I like the exposure, the exposure aspect of it.
Yeah,
I think also
yeah,
being comfortable with like not knowing the right answer and just building the confidence that you know you can figure it out.
Yeah, you shouldn't like let your insecurities and like thinking like, oh, I'm not going to be able to understand this, like you shouldn't let that get to you. That's the biggest mistake everybody does.
I agree. I agree 100%. Yeah, Psycode said the same thing. The part about self-studying and pursuing things and using the fact that you don't have the knowledge to propel you forward instead of discouraging you. Yeah.
Yeah, exactly.
Use the confusion to fuel the learning. I think, and I made actually, it's funny that we talk about this because this was literally, someone was posting about this on like, everything's connected at these points, but like, I was literally commenting this last night on LinkedIn on a post. Where is it? Where's this person? No. Where are you, dog? Jack. Yeah, this guy. Okay. Who apparently he teaches at like Cambridge or something. Zach, actually, shout out to Zach, by the way. Zach, I love having you as a buddy on LinkedIn because you always like really cool articles about education, and I just kind of like piggyback on it. But this guy talks about teaching, I think at the middle school, maybe high school level in Cambridge with physics. He deliberately does not give the students the answers first. He has them question and come up with like wrong answers and struggle. And then he talks about how like if you like design confusion correctly, he says like well-defined confusion is how like learning happens. And basically being comfortable with not knowing how something works and being confused, but building that skill to be able to then learn and understand. I think if that makes sense.
Yeah, I think I agree.
It's funny that you're touching on the same thing. I talked about this. I commented on this guy like last night. I was like, oh, this is really cool. But I said that it's especially rare today because a lot of social media, a lot of everything in life is very much geared towards like instant dopamine hits. And if you're not getting the instant dopamine hit, you can just swipe and just go get it somewhere else. So if, again, you're in any sort of like math or whatever science thing and it's difficult and you're not getting the dopamine hit of like, oh, like I understand stuff, I'm great, you're probably more likely to, again, quote unquote, swipe away and just be like, no, it's too difficult, I'm not going to do it, I'm not going to try. But the struggle is like where you learn. You have to struggle you have to not know shit and be disappointed and be confused in order to build the confidence to go learn stuff you don't know. That's my theory. Okay, cool. All right, Narosky, you want to do this? Let's do this. Let's do this question. This is the Eric.
Yeah,
this
sure.
is Eric's. And then Adar, Star Prod, Haunted. I see you guys. And then Hecker, can you put that screenshot in on the website so I can add it to the queue, please? And then we'll help you with that one too. All right. Suppose epsilon I are real numbers such that 0, so epsilon I is greater than or equal to 0, it's less than 1, and then alpha is equal to 1 minus a over b. Define capital N sub n by the recurrence. Okay, so we're saying the next term in n is equal to some factor to the nth power of the previous term plus some, I don't know, this is kind of like an error term, I guess, for m is greater than or equal to 0. And then is this the one, do we need to show this in order to show this, or are we just jumping to doing this, Narosky?
Well, yeah, you need to show, yeah, it's gonna show like in steps. I think the formula is actually wrong for the first one, surprisingly. Yeah, it's supposed to be, it's not extra, it's not like a big mistake. It should be alpha to the m times n, a sub 0.
Oh, this should be alpha to the m?
Yeah. Yeah. It's not a big mistake. It's probably just forgot to put it.
Okay. Not a big mistake.
So,
okay.
Yeah.
So how do we do this one? How do we start?
So they give you the pattern, right? So they say the recurrence is n sub m plus 1 is that.
Mm-hmm.
So
yep.
I would just sub in m equals 0, 1, and 2.
Oh, so let's just see like what the terms are. I think it's always like kind of a good idea, right? Okay.
Yeah, I usually do this. Yeah.
All right, let's do this. All right, so n0. Well, n0 is just whatever, I guess, right? We don't know what n0 is. Equals something. But then we could do n1.
It should be, yeah.
So n1
should be a real number.
Alpha to the 0, right? n0 plus epsilon 0. And then n2 would be equal to alpha to the 1, n sub 1 plus epsilon 1, and so forth. And then do I want to kind of show what alpha is? Oh, alpha is always just 1 minus a over b. Oh, okay. So in this case, anything to the 0 power is just 1. So this is n0 plus epsilon 0. And then this would be alpha n1 plus epsilon 1. Okay, cool. So then like n3 is equal to alpha squared n2 plus epsilon 2. Yeah?
Yep, I believe so.
And then I want to like come up with a pattern for what capital.
Oh, I see what. So I'm looking at the chat right now, and it wasn't making sense in my head.
Yeah.
They're saying they switched the alphas. Like it should be alpha and m in the recurrence, and alpha to the m and 0, right? So they forgot to put the m power there, and they put an m power there for no reason, right? So that shouldn't exist.
Oh, so this shouldn't be here.
Yeah, because it just doesn't make sense if it is there.
Okay, cool. All right, so let's get rid of that. Good eye. All right, we're gonna get rid of this. This is gone. Which, okay, so then that's fine. So then this is just alpha, right? This just keeps becoming alpha.
Yeah.
Okay.
So, okay, so then we're gonna have. So it's gonna be different then,
Okay.
right? Yeah.
So I don't know. I see that like n3 is equal to alpha n2 plus e2, but then n2 is equal to alpha n1 plus e1, and then n1 is equal to n0 plus epsilon 0.
Do you mind rewriting them like one below the other?
Yeah.
So it's yeah. So we can like have a clearer picture of what's going on.
One below the other. One below the other, he says. So, do you want me to write out like what n2 is here? And then say n2
Yeah.
equals? And then this is alpha n1 plus epsilon 1.
Yeah.
And then I'll write that n1 is equal to n0 plus epsilon 0. Kind of like that.
Isn't it alpha and 0?
Ooh, you are right. Yes,
Should be
you are
alpha
right.
and 0.
Yeah, how did I... Oh, you know why? Oh, because I thought it was alpha to the 0. That's right.
Yeah.
I was like, where did that go? Okay, got you. Got
So
you, bro.
then-
Okay, so then...
Yeah. Okay. Yeah, just another alpha there.
So this is like a bunch of Russian dolls like stacking into each other.
Yeah, can you plug in what n1 is into n2? So just go equals again at the there,
At the end of N2.
and just plug n1 in.
Cool. So that's going to be alpha squared n0 plus alpha epsilon 0 plus epsilon 1.
Okay, that we're getting somewhere.
I feel like that's right. Well, fuck.
Do you
Yes.
mind writing n1 as a summation? So it's like look at what they're asking us to prove
Mm-hmm.
for a second, right? So I want to show that there are all of the form like that form, right? So how about we try
I
to
see.
write each one like that? So it's gonna be alpha to the first power, like for
I
n1.
see how you want to write this. Okay.
Yeah. So,
So-
that n1 is just gonna be
N1
alpha to
is
the first power.
alpha to the first, n0 plus, and then what? This is the sum from I equals 0
To 0.
to 0, right? Of alpha 0
To the 0.
minus
Yeah.
alpha to the 0
Yeah.
epsilon 0. Okay.
Okay, yeah, so it works for n1. For n2 it's gonna be similar.
Okay. For n2, this is equal to, well, let's see. So that's alpha,
Alpha squared.
squared
Yeah.
and n0, right?
Yeah.
And then this is plus, okay, summation I equals 0 to 1 of alpha 1 minus I? Epsilon I? I think so, right? Because when I is 0, you get alpha to the 1, epsilon 0, and then when I is 1, you get alpha to the 0, which is 1, and then you get epsilon 1. Oh, okay.
Yeah.
I see. And then okay, so then
Okay,
n.
so
Should I do it for n3 or like I think we're
so
good, right?
let's do it. Yeah, let's do it for n3 and check if it matches. It should
Right.
match.
It should match, right?
eventually,
Yeah.
yeah.
Okay. So
But,
this
yeah.
would then be alpha to the 3rd n0 plus alpha squared epsilon 0 plus alpha. Oh, this is really cool. Epsilon 1 plus epsilon 2. Uh-huh.
Yeah.
And then yes, this is equal to alpha to the 3rd n0 summation I equals 0 to 2.
Yeah.
Alpha. What, is that 2 minus I?
Yeah, 2 minus I.
2 minus I.
Epsilon I.
Epsilon I. Got it. Okay.
So it
So,
works.
Am I
then-
allowed to just say that, like, let 2 equal m minus 1 and then we're Gucci?
No, we can just say like by induction. I think we don't even have to prove the induction. It's just very basic induction here. Right. If you want to, we can do it, but it's like just plugging in a few things.
I see.
So yes, so we checked actually 3 cases, which is way more than enough. So suppose
only have to check
for
one,
n
right?
greater than, yeah, only have 1 to check. In this case, of course. So just suppose that for any m that is greater or equal to 3, because we checked up to 3,
Okay.
it's actually greater or equal to 4.
For any m greater than or equal to 4, yeah.
Yeah, we have that, so you don't have to write it again. Yeah.
Well, I just have this. Oh, I see. I just have
Yeah,
this,
you
right?
have that.
Yeah.
Yeah.
Okay.
Yeah, don't forget the 8 alpha to the m, so you don't get
Right.
confused.
Yeah, we can't forget that one. Okay, this is to the m. Yep.
So we have this. Now we have to prove it for
m plus
n
1,
sub n plus 1. Yeah.
right? Okay.
So just write out n sub n plus 1. See what you get for it.
M plus 1, you get n plus 1 is equal to alpha m plus 1 n0 summation I equals 0. So it's m plus 1 minus 1, so that's just m.
Oh wait. What am I doing?
Is this just m? Is this
Yeah,
m
that-
minus
okay,
m
that's
minus
cool.
I epsilon I? Yeah.
Yeah, but we don't know this. We don't know this.
Oh, we don't know this.
You done messed up, Aaron!
I thought the induction was easy.
No, we don't know this for n plus 1. We know the recurrence for n plus 1. We don't know this formula. This is what we want to prove using the
Okay.
recurrence.
Okay.
So yeah, so keep the so for n plus 1 and just replace it with the recurrence for n plus 1.
Replace it with the recurrence.
Which you have it in the question.
Oh, I see.
That one. Yeah, exactly that one.
This one right here?
No.
Oh,
in
this
the
one.
question. No, in the question.
Oh, I'm fucking dumb, dude. Sorry. This one. Got it. This is
Yeah.
the one I want.
Yeah.
Yes. Okay. Gotcha. I see. And we try to make it look like that. That's what we do.
Yeah.
Dude, induction like continues to like from the grave just like come after me. Okay. So for m plus 1, this is true, right?
Yeah, and we know what n sub m is, so we just plug n sub n into this, and we're gonna get what we want.
Oh, okay. So then
Yeah.
you're saying I'm gonna plug this into here, sorry.
Yeah.
Okay.
Yeah.
So then m plus 1 is equal to alpha times all this, right? So that's gonna be alpha squared, right? Because alpha times this. Oh no, alpha to the m plus 1.
Yep.
Right. Okay. And then that's
N0.
n naught, n0.
Yeah.
And then summation I equals 0 to m minus 1. And then this is alpha to the 1. Right?
Sorry.
But then it's times alpha m minus 1 minus I epsilon I.
Okay, yeah. Yeah.
this and this will cancel out, right?
Yeah, and don't forget plus epsilon m at the end.
And then, yes, good. And then plus epsilon m. So I have alpha. Let me get this. Alpha m plus 1 n 0
Plus the
plus
summation.
I forgot the plus. Then summation I equals 0 to m minus 1, and then this is alpha to the m minus I.
Well, if you're doing it from I equals 0.
Uh-huh.
Oh, okay, yeah, never mind. Yeah, that's okay.
Okay.
Yeah. I was gonna say you're gonna plug m in, like epsilon m, into the summation, so you're not gonna write.
Oh, you want me to
outside.
include this one in here?
Yeah, so it's just gonna be 2m instead of m plus 1. That's the only change that happens.
Let me think.
Do you see why?
I see. You're gonna say this goes to m, right? Okay, because when I equals m, you get okay, got you. So
Yeah.
bringing this in, when you have summation I equals 0, and then when it's m minus m, I get it. That would just get you alpha to the 0, which is 1, which would get you this. Oh, okay. That's clever. M plus 1 n 0 summation I equals 0 to m minus 1. No, to m.
To the m. Yeah.
Okay. Alpha m minus I epsilon I. Okay.
Yeah. Which
And is
was
this
what we had proved.
Oh, and is that what we're trying to prove?
Yeah.
Well, we had m minus. Oh. And then you say, but let m plus 1 equal m minus, because I see. M plus 1 equal to m,
No,
right?
So you're supposed. Wait. Pause. 1 second.
Pause.
So, what induction says is, you suppose the case for m,
Yes.
and you prove it for m plus 1. We have proven it for m plus 1. So therefore, our previous assumption of n sub m is true, and it holds. And since we have proven it for any m, we don't have to do anything else other than just write that it is finished. The induction works, and it is true for any m.
For any m. Yes, this is true for any m.
So yeah.
Oh, which matches kind of what this. I'm always like, do I want to like compare it to this? Do I want to say like,
No,
hey,
you
this?
don't. You don't want to compare it to this. You have compared it to this. You have done this.
Because that's what I'm trying to prove, right? Is that what I'm trying to prove?
Yeah.
I'm trying to prove this. Yeah, right?
Show this. Yeah. You suppose
Okay.
it's true, and you show it for the next case.
You show for the next case, okay. And then
Yeah.
in my
So then-
mind,
yeah.
I kind of start thinking of this kind of like a U sub thing, where I'm just like, oh, well, you know,
no.
what if U equaled m plus 1? And then literally that would be NU is equal to alpha to the U, right? I don't know. Maybe I'm
Yeah.
crazy here.
So imagine if we shown it. What did we do before? So we showed it's true for one.
I got it.
So
Right.
we showed it's
Yes.
true for 1, and we proved it for 2. We showed it's true for 2, and we proved it for 3. This
Yes.
does it generally.
This says for all m.
Yeah.
Got you. Dude, eventually one of these. It's so funny. It makes sense to me right now. I guarantee it'll confuse me tomorrow though.
Yeah. You
Dude,
just have to remember. Yeah.
I just have to
You-
keep
you
hitting
just
my
have to
head against the
remember,
wall
yeah,
with induction.
it's,
I fucking hate induction.
Yeah. We can do a few induction questions when it's.
Let's do it on
tomorrow.
Friday. Yeah.
Yeah.
I always have these like aha moments with induction, and I think I just need enough of these until it eventually sticks.
Yeah.
Yes, and then you're done. I like just don't trust it. I don't trust that this means we're done. Okay, but I think it works. Okay, cool. Wait, but that's just part A. How do we figure out part B then?
That's part A, and part B is simple because you compare with geometric series.
Okay.
Yeah.
So how do we compare this with the geometric series?
Okay, so
Is this
what
like a
is the
squeeze
minimum?
theorem?
So check. What we're given is that epsilon I is between 0 and 1.
Yes.
So the sum is greater or equal to 0, evidently.
Sure.
And what happens when epsilon is
0.
0?
This whole thing goes away.
Yeah.
And I'm just left
the
with
minimum
this.
is just that's the
Okay.
minimum.
Oh, okay.
Yeah.
Oh wait,
And
so
the
wait.
maximum is
Should
Yeah.
there be an M here?
I don't remember.
No, I forget. Wait. No. We had this.
Yeah, there should be an M there. Yeah, there should be an M there.
There should be an M, right?
Yeah. Okay, yeah.
Okay, there we go. We flipped it. All right, thanks. Yep.
Oh, yeah.
Right.
Okay.
Good.
All right, and then the maximum occurs when epsilon is equal to 1, I
It
guess,
cannot
right?
be 1. Yeah. We
Or
can
less
say
than 1?
Yeah, when it is 1 because that's the maximum anyway. It doesn't attain its maximum, but that is its maximum.
It's
at the
bounded
limit.
by it. It's bounded by it.
Yeah, it is
That's right.
bounded. Yeah. That's what we're trying to show.
Okay. So if I plug 1 into here, right? Then yeah, this will be whatever alpha to the m. But then I guess I want to show what this is. And this you say is a
We're
geometric
gonna
series.
Yeah, we're gonna show. So what? Okay, let me take a breather.
Yeah, let's take a breather. Chill.
If epsilon is less than 1, right? What is this whole sum gonna be less than?
This whole thing, less than the sum of this, I guess.
Yeah, exactly. And that is a geometric series. Because it
Right.
is the sum of alpha to the power of something.
Yeah. So
And we know
the,
we know the formula for that.
the sum of I equals 0 to a of what is it? Well, I forgot what this. A, and what is this? Like x to the I? This is something, I think, right? What's up, Becky? Back?
Yeah.
Good job.
Is this the 1 over 1 minus r or some shit? What is this?
It's 1 minus. It's complicated. I don't even know like how you.
I know the infinite one is a naught over 1 minus r, right? Oh, I found it.
Yeah. Yeah. It's
Found it.
Yeah. Sure. Okay.
Right? I feel like this looks.
Yeah.
This looks not sketch. Becky Beck, what's up? How you been? Becky Beck used to always give me really difficult questions as well. Becky Beck.
Oh, Becky, I remember.
You remember Becky? Yeah, back from when we did like the
Yeah.
24-hour stream, and Becky was always giving me, I forget what type of questions but they
Epsilon delta.
made my brain hurt. But maybe I'd be able to do them now. Okay, so this is so in this case x. Well, fuck. She did not give me optics, no. I think it was discrete. I think it was discrete math is what it was.
Yeah, it was discrete math. It was.
And there was like epsilon delta
Epsilon
shit in
delta
it.
definition,
Oh, I
yeah,
fucking hate epsilon
epsilon.
delta. I hate epsilon delta, dude. This shit gives me nightmares.
Yeah. So that's the general formula for it. It doesn't. Yeah.
Yeah, this
where,
sorry, this is a to the n. Or no, is it r? No, sorry, it's
So R is the ratio between.
a times r to the n. This is it, right?
Yeah.
Or what's sorry, r to the I, and then this is I is equal to 0 to n. That's what this is, I think. Yeah.
Sure. Yeah.
Sure. Okay. So in this case, this is a, so a equals epsilon I. This is kind of weird though. This thing. I don't like this. I don't like this geometric theory series thing. Oh, is this like this fucking off by 1 thing or something?
What?
No.
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 Okay. So can we like write it because it's difficult to speak like in terms of like 3 variables at once.
Yeah. No, I got you. Okay. So I want to figure
Alpha,
out.
M and I. Yeah. Okay.
Okay, so the summation from I equals 0 to m minus 1 of alpha to the m minus 1 minus I, epsilon I, right?
Yeah.
And in this case,
We don't want to find what this is. We want to bound it. That's what
We
we're
want to
trying
bound
do.
it.
So it's
Okay.
It's gonna be less than something. So we
Okay.
discussed this. It's gonna be less than the sum of alphas.
Okay.
Yeah,
Oh,
alpha to the
oh.
m minus 1 minus I.
Alpha to the m minus 1 minus I.
Yeah.
Oh, because epsilon I is always less than 1.
Exactly.
Oh, yeah, duh. Okay, cool. Got you.
Yeah, and this the right hand side is a geometric series with yeah.
Yes, in this case, R is equal to alpha, I guess? Or is it,
So R is equal to 1, no?
Oh, R is equal to 1. Oh, and then we just leave this how this is? Wait.
Yeah. No?
But
Or am
this
I-
has I's in it and stuff, right? No?
Oh yeah. Wait.
Yeah,
Let me be careful.
wait. Yeah, we gotta be careful. Wait, I
So
think this
can you write it out as like
A fraction?
instead of instead of summation, can you write it like something plus something plus something, like write it out
Okay,
instead of
right.
using the summation notation.
Okay. Yes. So that's alpha to the m minus 1 plus alpha to the m minus 2 plus alpha to the m minus 3.
Plus so on plus 1.
Plus so on. Yeah, and eventually you get just plus 1.
Yeah. So
Okay.
this is the geometric series of alpha to the power of something. Right, which is just gonna be 1 minus alpha to that power. No?
1 minus alpha to that power. Is that this? The summation? Sorry, let me think here. Also, wait, we said it eventually goes to 1. Why? Because eventually you're going to a to the negative infinity? Is that what we're saying? Isn't this plus 0 eventually?
No, it's plus 1.
Why is it plus 1?
Because the ratio is gonna be alpha, I believe. No? Check what is alpha to the m minus 1 divided by alpha to the m minus 2 is gonna be alpha. Right, so that's the ratio. The ratio is the
Oh, okay. The common ratio.
how do you say yeah,
Yes.
the fraction between
Yeah. Common ratio is alpha to the, what is it, m plus 1 over alpha to the m,
sure, yeah.
which is the same thing as
Oh.
alpha to the m minus 1 over alpha to the m minus 2? Or no, sorry, it's the next term to the first one, right?
Yeah, so it's alpha to the m over alpha to the m minus 1.
Okay.
Yeah, the ratio is just 1 divided by the next one, right?
Yes.
Yeah, so it's just going to be alpha to the power of m minus m plus 1, so alpha to the first power, which is just alpha.
Got you. Okay, I think I
So
get that.
yeah, that's the ratio, and if you plug in the ratio in the formula,
Into this formula here. Thank you, Sharon, for the heart.
Yeah.
And thank you, Kilobyte, for the follow. So if I plug into here,
Yeah.
sorry, where R is the ratio, right?
r is the ratio and it is equal to alpha.
Okay. So then I have, and then the first term is 1. So you're saying 1,
Yeah.
and then this is alpha to the n minus 1 over alpha minus 1.
Yeah, precisely.
Okay. But then this goes to m minus 1. So n is equal to m minus 1, right?
Yeah.
Okay. So that's alpha to the m minus 1 over alpha minus 1. How are we going to make that look like this, though? Oh, we plug in what alpha is. Alpha is 1 minus a over b, right?
Wait, I'm kind of confused here for a second.
Yeah.
Because why is it alpha to the m minus 1 and not alpha to the m?
Because isn't the nth term like the end of this, right? Wouldn't the nth term be m minus 1?
Yeah, but I vaguely remember, like I actually not vaguely, I definitely remember it being n plus 1, not n, like the ratio to the power of n plus 1.
Oh, you're saying this formula is wrong?
I'm saying it's ever so slightly wrong. Because how many terms do you have? Right,
Well,
that's
let's
how
see.
I'm thinking about it.
Oh, you know why? Because they have these
They go
fuckers
from
starting at
1.
1. Yeah.
Yeah, exactly.
Oh, these
'Cause
motherfuckers, dude.
n is the amount of terms that you have.
Wow. Yeah. See, this is why you gotta be careful. Yeah, they.
Yeah,
Man.
see?
Yeah,
They
I
start
see.
from a plus
Yeah.
AR squared.
Yeah.
AR,
Okay,
yeah.
let's get rid of this. This is wrong.
Yeah.
So I can't.
So
you have to be careful about just like randomly copying things from Google Images.
This is also wrong.
Sorry, this one's also wrong. Sorry. Yeah, you're right. I need.
Yeah, we can
where's the-
just write it ourselves. We can just write it ourselves
Okay. Yeah.
instead of trying to find it.
I was like, I feel like maybe it's this one. Is it this one?
Yeah. Okay. This is right. Okay. Wikipedia as always.
Bless Wikipedia. Okay. Right. Okay. Because this is the R to the 0. That's the first term you're saying, right?
Yeah.
And then
Yeah,
as they
fine.
go up. Oh, so you did it in like reverse order. I get it. Like this is the greatest term, right?
Yeah.
This is the least term. Oh, I see. It's backwards.
This is the derivation. This is how you derive the formula.
Okay. Okay. So,
Yeah.
that's going to be 1, and then it's 1 minus alpha to the m minus 1 plus 1 over
Yeah.
1 minus alpha.
Yeah, really. Wikipedia is like notoriously bad at explaining math, but it's a pretty good source of finding formulas.
Yeah.
In my
1
opinion.
minus alpha to the m over 1 minus alpha. Oh, is this where am I finally going to plug in alpha equals?
Yeah, you're gonna plug in alpha.
Okay.
Yeah.
But alpha equals 1 minus a over b. So we'll plug that in. So 1 minus a over b to the m over 1 minus 1 plus a over b. So that goes away.
So it's just gonna be b over a times times that. Yeah.
B over a times 1 minus a over b to the m. Okay.
Don't forget the equals because it's not gonna make sense in
Equals.
the photo.
Yeah. Okay.
You always have to think like how the reader is gonna interpret it, right? So if it's messy, it's not gonna be clear.
Oh, am I then thinking about like how this can be bounded? Right?
Yeah, we can easily bound this to be less than b over a.
What do they
believe that's
say?
clear.
Do they say anything about A and B? They don't say anything about A and B.
No, they don't need to say anything about a and b other than a should be non-zero.
Okay. So the
Yeah,
biggest this could be
and-
is 1. So this is less than 1.
Yeah, exactly. This is less than 1, so it's gonna be less than b over a.
Good. I see. So then we can just plug that in. And I think we're good, right?
Yeah.
Yes. Nice. Okay, cool. I think we got it. Oh my god. Nice. Eric, does that answer your question? That was actually pretty fun. I appreciate the struggling. The struggling is fun. I'm eventually gonna get integration by parts stuff. Here, let me put that in because I want to put like where that solution was. How do I do this? I need to download. Here. Let me download this. I'm gonna say this was Eric's. Thanks for no, of course, dude. I learned a lot from that. Yeah, I love these types of questions because I learn. You said Ben asked it. Was it someone else in your stream, or was it was in one of Zach's streams? Wait. Invalid security token. What? Fuck. Okay. I don't know why it says invalid security token. Yes, Adarsh,
kind
you
of-
are next. Don't worry, I'll do you next. What's up, Machka?
What?
What's
I'm
up?
looking through the queue and there's there's a biology. There's something about biology, and it's written in Comic Sans.
Is it? What does it say?
I think so. Or maybe I'm just like not remembering fonts, but it looks very silly.
Or maybe it's written in what's the other font that they use in like Avatar and stuff? Ian Stuckey, why can't I upload this? I want this to work. Oh, Papyrus. It's Papyrus.
No, it's not Papyrus. Papyrus, I remember vaguely, it's very sharp. This is just very round and silly.
Whose is it? Is it Haunted's? This one?
No.
Oh, this?
Yeah.
Yeah, this is man. This font is like I think it's called Calibri. I want to say it's Calibri.
Yeah.
Yeah, I think it's Calibri font. Or maybe it's not
Oh, it's not.
Calibri. No,
No, it's not. It's not.
it's a. I know what you're talking about. It is like a font. It's like a goofy ass font though. I don't think is it Comic Sans? Oh, it is Comic Sans, I think. Oh, it is fucking Comic Sans. Oh my god. The one I'm thinking
Wow.
about, Papyrus.
It's very,
Yeah.
yeah, it's very sharp.
Papyrus font. There's a whole Saturday Night Live skit with it too. All right, one sec. I'm almost there. I want this to work. Okay, 5 posts. Technology. Okay, there we go. 5 post Eric's. Good. And then delete Eric's. And then Adarsh. I got you. But then I do want to save this solution. Eric Ben. Cool. All right, let's see what we got. Not podcast. There we go. Dun, dun, dun. Not that. There we go. Adarsh. Prove this. Ooh, okay.
Oh, this is simple.
Yeah.
Yeah.
Let's see what this is about. Okay. Cosine squared plus cosine squared x plus pi over 3 cosine squared x minus pi over 3 is equal to 3 over 2. Do I have to do this, I don't know, like addition and subtraction rules for cosine?
No. So what is cosine squared of t?
Oh,
It's gonna
1
be
minus
1 plus.
1 minus sine squared?
No, we want it in cosine.
Yeah, you wanted cosine.
Because you're gonna get negative numbers if you don't, I believe.
In my mind, I feel like I feel like I want the equation for like what cosine of like a plus b is.
You do, but not right now because
Not
it's
right now, it
squared.
says. Okay.
So we're gonna just replace all of the squared cosines with its double angle identity. So it's gonna be cosine squared of t is gonna be 1 plus cosine of
2x like
x,
that.
yeah, over 2.
And this is all over 2.
All over 2. Yeah.
What's up, Jeff? Write it in Zach format. What's Zach format? Let me shout out some people real quick. One second. Let me shout out. That's Eric. Sorry, Zach format. Yeah. I don't know what Zach. Oh, he's talking about Euler form. Also, let me shout out Eric.
E to the power of something.
Okay. Is this like calc or something like this? No, I think this is just pre-calc. So what? This is 1 plus cosine of 2x all over. Well, they're all over 2. So can I just like multiply everything by 2 and just make this equal to 3?
Yeah.
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 Okay, so then this is 1 plus cosine of 2x plus 2 pi over 3 plus 1 plus cosine of 2x minus 2 pi over 3. And then this is all equal to... It was all over 2, and then this was equal to 3 halves, but then what I'm going to do is I'm going to just multiply both sides by 2.
Yeah.
So, here, I can actually copy that. That's fine. So let me get this is just that over 3. Okay.
Yeah, and you have 1 plus 1 plus 1, so you can just sub out 3.
1 plus 1 plus 1. Oh, that's super fun.
Yeah.
Okay, this and this and this is 1 plus 1 plus 1. And that's equal to 3, so then that'll cancel with that. Okay, cool.
Yeah.
So then we have cosine of 2x plus cosine of 2x plus 2 pi over 3 plus
Yep.
cosine of 2x minus 2 pi over 3 is all equal to 0. Ooh. I guess I want to show that this is somehow this.
Yeah, and it is, because it's going to be negative that.
Yeah,
And for good reason, because what is the formula for cosine of a plus b plus cosine of a minus b?
I don't know. Did I need to look that
So
up?
what is no, you don't. So
I'm not
you
gonna look up
definitely
anything.
know it. You definitely know it. What is the formula for cosine of 2x?
Oh, cosine of 2x was equal to, isn't that, wait.
No.
Wait, it's what we just said it was. Like this one? It's equal to 2 cosine squared minus 1? Or, I don't know, is this sine x, cosine x?
It's gonna be what?
No. What's
No.
cosine 2x equal to?
So it's either cos squared minus sine squared.
Ah,
Or-
okay.
Yeah.
Yeah, see, I know this one is somewhere. I don't memorize this one off the top of my head.
Yeah. This is generally. Yeah.
Okay.
Alistair did write the right thing in chat.
I see that. That's the one
By
I'm
the way.
looking for. I want that one.
Yeah.
I want
Yeah.
that.
I was gonna say you don't need to use this. I was gonna say like you don't need the formula for the first one because it's gonna be useless in this context.
Okay.
See, what you want to notice is that the arguments of the last two terms are actually, if you denote one to be, like, if you denote a to be 2x plus, yeah, that is going to be a plus b, a minus b.
Oh, I think what you're saying. You're saying like a plus b, a minus b.
Yeah, exactly.
Okay. Which is equal to
So
2 cosine ab.
Yeah, 2 cos a to cos b. Yeah.
Okay, let me explain that for Adar so he understands it. So you say let 2x equal a 2 pi over 3 equal b.
Yep.
Then cosine of a is what this is now, right? Cosine of a plus cosine of a plus b plus cosine a minus b, right?
Yep.
Equal to 0. And then this whole thing is equal to 2 cosine a cosine b?
Yep.
Yeah, see, that one I don't know off the top of my head. No.
But you do know the formula for cosine a plus b, right?
I don't think I do. Is it like cosine, cosine, sine, sine? I think that's what it is. Cosine a plus b.
Yeah.
I think it's equal to like cosine a cosine b plus sine a sine b.
So it's going to be minus. If
Minus.
it's sine, it is plus. Yeah, if it's sine, the sinus has plus between. Like if it's sine plus, it's gonna be what you said plus. But the cosine like inverts the sign.
Got you.
Yeah, this is cos a plus b. If you write cos a minus b underneath it, it's gonna be what you just said, but with a plus there.
Yes. Yeah, it's
Yeah,
plus minus
and-
is minus plus. I remember this one.
Yeah, and you can
Okay.
derive what we just said by that.
Uh-huh.
Right.
Yeah,
It's-
okay,
yeah.
okay. Okay, I get it. Yeah. Because you would just double up on these. Yeah.
Yeah, exactly. So yeah, so you'd have basically
So we have this.
yeah.
And then I'm
But
gonna.
you know what cosine of b is, because b is a fixed variable. It's 2 pi over 3.
Oh, okay. But b equals 2 pi over 3. Oh,
Yeah,
very
so cosine
cool.
of b,
Cosine of 2 pi over 3. That's equal to negative 1/2,
yeah.
right? And that comes from the unit circle, Darsh. This is 2 pi over 3. You're looking at this part, and this is negative 1/2. Okay. Oh, okay. So then I have cosine of A plus 2 cosine of A, and then times negative 1/2. Okay, but this cancels.
Yeah.
Okay, and
And
then
you're left
I got
with-
you.
Yeah.
Beautiful.
equals to 0.
Cosine of A minus cosine of A is equal to 0. 0 equals 0, and you're done. Wow. That's cool. Okay, so a couple identities you needed to know. And I agree with Jeff that you don't need to memorize these because a lot of times your teachers will give you these. Maybe not in Romania, but in the US and Canada, they will give you this. And I think they'll definitely give you this one as well.
Just yesterday, I was in class and some students forgot the formula for I don't remember, like sine of sine A plus sine B. I don't exactly remember, like the sum of two sines.
See, yeah, I don't know if I know that. I know they flip it up. I know it gets flipped a bunch of times. And then this is 2.
Turning turning a sum into a product. That's what they forgot, and they were threatened with they were really threatened with bad grades for that.
Yeah, that's these. I know it's all these ones. Yeah, this.
Yeah.
Right. This one is not as well known.
Yeah.
Yeah, actually, a lot of these aren't really very well known. What's the one that we always learn? Why was it for accept mental exercises? What do you mean by ear? What are you talking about? What's up? I think this is the one. Okay, these are the ones I always remembered. But I think what you're saying is that you can eventually rederive all the other ones from it, right?
Yeah. If you know the basics, you can just derive them.
Yeah. Oh, fuck. One sec. Too many of these. Yeah.
Yeah, but when you're in like a high performing class, you're supposed to be like, oh, how do you not know this, right?
Yeah, no, I get it. Yeah, these are useful. Can you derive the basic one? What do you mean the basic one?
Yeah, from geometry. Like
Geometry?
Sin A plus B from geometry. Yeah.
You can derive this from geometry.
Yeah. Just.
What's up, Kempi?
Triangles, I believe.
It all comes down to triangles. Blessed triangles. Jeff's second favorite shape. All right, nice. Okay, cool. Great. All right, that was a Darsh's. Let's see if my thing's working. Mark done. And then that's gonna get put in our Discord. And then we'll drop a screenshot in. Nice. And then there you go, Darsh. Oh, what the hell? Why did Spotify come up? I have great news. I got an A- on my first integration quiz. Congrats, dude.
That's dope.
Good job, Kempi. Hecka yeah. What about hexagons? All right, let's see. Hess's law. Ooh. Now, StarProd, to do these types of questions, you usually need a table. You can't tile a sphere with hexagons, but you can with heptagons. Oh. Is that where soccer balls come from? Yeah, I think we need a table for this. They usually need to give you like a series of reactions. You want me to go find them? It proves that spheres aren't flat. Don't you have to find the reactions? These have to be given to you. You need yeah, let me they have to give you a table of them.
I'd love to pretend like I know what this is about, and I should know what this is about, but I don't know what this is about.
It's Kev. It's you just have to like put a bunch of equations together and then make it look like something else. It's doing this.
Oh. Yeah, no, I know what it's about because I should know it, but I don't know it. That's the whole point. I did this. I did do this at some point.
Yeah. Yeah, you need the delta H's table. You can't do this just like out of nowhere.
Oh, yeah.
Let me think. They have to give it to you. Let me think. FE203 and AL. Yeah, send me your textbook ones. Yeah, it should be there. There's like an infinite number of these things. Right? There's an infinite number of reactions, so I can't like just look up like I think here you go. Maybe this will help us. This is Fe and CO. What do we need to go? No, I need Fe and aluminum. Okay, I think this is it. Yeah. Here we go. These are some reactions. Because what do we have? We have Fe203, Al203. Okay, there we go. Yeah, this, except fuck, I don't have Fe203. Oh, I do have Fe203. Okay, good. And I do have Al, and I do have just Fe. Okay, there you go. I figured it out. Just gotta Google around. Yeah, standard enthalpy of formation. Yeah. But do you see how this is like, I don't think you want this. I guess you could though. Wait, can't you use the standard enthalpies for each one individually? Is it just products minus reactants? But I don't think this is usually what Hess's law is. Oh, this is it. Okay, yeah. Delta H F products minus delta H reactants. Yes, but how do the subscripts work then? We'll try both. Because usually this is what they do. They'll give you two reactions here. And then you figure out what the final one is. So, for instance, this one, you're trying to get Fe203 on the left. So that's this one. So let's call this like equation 1. This is equation 2. But you want this one flipped. So I'm going to say 2Fe2. 2Fe2O3 goes to 4Fe plus 3O2, and then that's going to be a delta H equal to 1644. Yeah, that's one way to do it. This is the standard, like, Hess's law way of doing it, is doing this. And then we're trying to get to... And then I need Al2O3 on the right. So this was, like, -1 times equation 2. And then I'm going to add this one. I'm going to say 4Al plus 3O2 goes to 2 Al2O3, and that has a delta H equal to negative 3338, and that was from equation 1. And then what happens is if you add these, watch what happens. This cancels with this, and you're left with 2Fe2O3 plus 4Al goes to 4Fe plus 2Al2O3. And then the delta H there total is equal to this plus this. So that's 1644 minus 3,338. Okay. But they want it for basically half this reaction. Because see how there's a 1 in front of that? There's a 2 in front of the Al. Here we have a 2 in front of the Fe, a 4 in front of the Al. So what I eventually want to do, I think, is I just want to like divide this all by 2. Right? And then I divide this by 2. And so then that gets you the reaction you want, which is this. And then that's equal to delta H. Let's pull it. I need a calculator for this one. All right, let's see. 1644 minus 3338 divided by 2. So that should give me negative 847 kilojoules. Okay. Let's see if it works out the same way, doing just heat of formation for everything. Okay. So this is one way to do it. Knowing that if you have the enthalpy changes for standard reactions, you try to use some combination of these to create your final reaction that you're trying to solve for. You could also do it with this. So what do I need? I need Al2O3. Well, this is a mess to look through, but for sure. Okay, so you have that one. Control F. Oh, I guess it does work to Control F things. Okay. I don't know if it was... Okay. And then aluminum. So anything that's a solid has 0 heat of formation. I think anything pure like that, right? I don't think Fe has anything too. Yeah, the heat of formation of like a pure element is just 0. And then Fe2O3 is this. Oh, look, you're just going to get the same answer. Okay. And then it's just products minus reactants. Yeah. So this is just 1669.8 negative minus, and then that's going to be negative 822.2. Which I think is going to get you the same thing. Negative 1669.8 plus 822.2. Yeah, you get negative 847.6. Wow. Okay, cool. Yeah, that's one way to do it. I think more often what I see in chem classes, though, is they're going to do this. They're going to give you certain reactions, and then you have to come up with, like, what clever combination of adding them up or, like, flipping them will get you the reaction that you're looking for. This works as well. And then I think if there's just numbers in front, like in this case, I think you just multiply it by, like, whatever the number is. There's one where, like, the coefficients becomes exponents, and I want to say that's for equilibria. Yeah. Okay, cool. Nice. Cool question, Star Pod. 2 ways to do it.
Well done! Well done!
Alright, then Haunted, you're next. Can you do the 7 if possible? You want me to do all 7 or just number 7? Number 7? Okay. Yeah, I can do it real quick. Alright, H2SO4. You also gotta make sure stuff's in the right state. Okay, there's H2SO4. SO2 gas is here. Haunted is, yeah. Haunted's in our Discord chat or Discord stage. Eric. H2 does H2O have a heater formation? Oh, I guess it does. There's H2O, and then you need... And then O2 doesn't have... O2 is standard. I want to say. Yeah. If they have ions on them, like if they have ionic charges, then they're not 0. But this is like the natural form for oxygen, so we don't care about it. Okay. So this is just products minus reactants. So I think you just add these two up. So I think it's negative 296.1 plus, or minus in this case, minus 285.8. So this is the products. And then you subtract that from the reactants, which would just be negative 811.3. So what is that? Negative 296.1 minus 285.8 plus 811.3. So yeah, this is just 229.4. Kilojoules. Do I think it'd be something similar? Yeah. Now, you know, and I told you this, Star Prod. I think this is more what you would see on an exam for something over Hess's law. I think they're gonna more likely do something like this. Just like looking up tables and doing products minus reactants is kind of boring.
Disqualified.
This requires like some fun and some math. And yeah, if for instance, if you were to look up just like Hess's law questions, here, I'll put this solution in there too for you. If you were to just go to Google and be like Hess's law questions, more often than not, yeah, this is what they do. They give you calculate delta H for this reaction, and then they give you all the other delta H's, and you're supposed to do this. Yeah, you see here it says Hess's law can be used to calculate it that do not normally place. Calculate the enthalpy change for the reaction using these following reactions. So you have to use these as building blocks to try to make this top reaction. Yeah. Infinite numbers of these. Yeah. This is all Hess's law. Cool. All right. Let's see. What has Haunted got for us? When it's my turn, I don't understand how the grid was made, how the sum equals 0, negative 2. Okay, cool. Let me pull it up for you. To find the equations? Yeah, they're usually given to you, though. What I would say. To go find them, yeah, then to me that says... dude, why is this not copying correctly? Copy image, please. There we go. Now it's uploading. Okay, cool. All right. I don't understand how the grid was made and how the sum equals 0 and negative 2. All right, pulling this in. It's very high resolution, apparently. There we go. Yeah, look as well. I can see like the individual pixels. Okay. Far from being a charming theoretical oddity of infinite series, this phenomenon can be the source of great consternation in many applied situations. How, for instance, should a double summation over two index variables be defined let's say we're given a grid of real numbers, A, I, J, where I and J are natural numbers, where Aij equals 1, what is this? The fuck is this saying? Sorry. 1 over 2 to the I minus 1 if J is greater than I. Aij equals -1 if J equals I. And Aij equals 0 if J is less than I.
Does he know matrices, or is this for something else?
Haunted, do you know matrices? Are you okay, Hacker? We're still here. Haunted briefly knows to it. Okay. We would like to attach a mathematical meaning to the summation this. You haven't taken linear... Haunted has not taken linear algebra.
That's a problem.
That's a problem, apparently.
Disqualified.
You have to understand somewhat like what a matrix is, right? I think IJ is row column, right?
Yeah.
Yeah.
This is why I asked if he took linear algebra, because that's like that's explained like in the first few lessons.
Yeah. So Aij, right? This is the row, and this is the column. And we said that if J equals I, then it's equal to -1. So that's why all the dag. You know pre-calc matrices. Okay. So this is why all the diagonals are -1, I guess, right? And then there's 0 if the row, if the column is less than the row, right? Okay. So these are the rows. So if you're in column 0, right? Or I guess column 1. Wait, no, column 1, right? Because, 0 is not included. Yeah, okay. If you're in column 1, anything that has a row greater than 1 becomes 0. Right, because this is row, say like column less than row. Yeah. Okay. So that's why these things are all 0. This is an upper diagonal matrix, I guess, right? And then, sorry, they said this is 1 over
Triangular.
2. It's triangular, sorry. And then this is 1 over 2 to the... Is that J minus I see? J minus I?
Yep.
Okay. Where J is the column. Okay, so this is column 2. 2 minus 1. Right, that's why it's 1/2, 1/4, 1/8. Cool. Okay, I understand how the matrix... I'm so dumb that makes sense. No, it's okay. Okay. You remember now? Okay. Alright, so that's how it's made. A moment's reflection, okay, shows that each row sums to 0. Oh, that's cool. Because is the sum of this equal to 1?
Yeah, the sum of 1 over... Yeah, you can use the geometric formula.
Oh, no.
Series.
We can literally use what we just did. Yeah, where was it? Where was that bitch? Where's she at? Not that one. That one's wrong.
Here. And
This one.
You said you know it for... you said you know it off the top of your head for infinite
For
sums,
infinity,
and that is an
yes.
infinite sum.
I do actually.
Yeah.
Right, yes, okay. So the sum for n equals 1 to infinity of... I always forget this was a r to the n is equal to a over 1 minus r, right?
Yeah, and in this case, the
this
ratio
case,
is just...
R is equal to 1/2. And then a is equal to 1, right?
And the first term is... No, it's 1/2.
Oh, it is 1/2. So R equals 1/2, A equals 1/2?
Yep.
Okay. So when you sum across this way, right, Haunted, that becomes 1/2 over 1 minus 1/2, which is just equal to 1. And then the sum of that plus that will be equal to 0. That's super cool. We could have also as easily decided to fix J and sum down each column. Wait, is the sum of each column is -2? Where does that come from? Oop. I don't believe the sum down. What? The notation makes it look more complicated than it is. I agree. Sorry, they say fix J, so IJ, so fix the column and sum down each column first. In this case, they say...
Oh, so it tends to. It goes to.
It goes to. Oh, sorry, this is summing over all the...
Yeah, it never is.
This is summing over all the columns. And then this is... You're going down the rows, right? You're saying that equals -2? Or it tends to -2?
Yeah,
Why is it
yeah.
Oh, I see. Because it's -1, and then it's -1 plus this, and it's -1 plus this, and it's -1 plus this, and it's -1 plus this. Is that what we're saying?
Yeah.
And,
So
okay.
it's just going to be -1 minus 1 over 2 minus 1 over 4. Yeah.
I see.
So it's just what we had before, but instead of -1 plus that
it's
sum,
negative.
just...
It's -2 because
Yeah. It's no longer -1 minus the sum.
Gotcha. Well, there is a -1 from here, right? But then this sum is then this -1, right? So you're saying these eventually go to 0?
Yes.
Oh, here's actually
Yes.
you could actually also look at it this way, right? Look at this, Narowski, right? This cancels with this, right? And then like whatever, 4 of these will cancel with this. I don't know. Start to see.
Oh yeah.
Right?
Wow.
Right? These two would cancel with that.
Yeah.
These two would cancel with that. I don't know. And then eventually like 4 of these would come in and cancel out with one of these, and then 8 of these would come in and cancel with the other one. But I guess one of them is left over at some point. I'm trying to see if I can see how that is. Okay. Cool. Alright. Does that make sense, Haunted? What book is this for, by the way? Like, wait, what are you doing for this? What class is this for? It's kind of mean.
There is a nice way to define this matrix.
Uh-huh.
Like, do you know piecewise I suppose you know piecewise functions. You said you took calculus 3. There's no way you don't know piecewise.
Yeah, we know what piecewise functions are. It's Understanding Real Analysis by Stephen Abbott.
Very nice. You can define this to be matrix A, right?
Okay.
So let's just say it's A, big A.
Okay.
So a capital A is the matrix.
Capital A is a matrix. Infinite matrix.
Yeah.
Which is equals infinity by infinity. Uh-huh.
Of the, like a piecewise, how do you call it? Like a...
Like that?
Yeah, and for the first one, I forget what it was. So I just want columns, rows, and like, yeah.
Oh, I see. I see what you're gonna do. You're just gonna add them up to each other, right?
No, because it's gonna be, so we're given a grid, right? So Aij is okay. So yeah, define the matrix as that. Yeah, 1 over 2 to the power of j minus I.
Yeah.
Yeah, if j is greater than I.
Yeah. And then it's -1.
J equals 1. J equals I, yeah.
J equals I, right?
So on the diagonal. On the diagonal, and 0 if it's less.
Yes. Uh-huh. Okay, so we just rewrote this in like piecewise form, sure.
Yeah. And above, like where you wrote the matrix.
Yeah.
Yeah, Ij, exactly, yeah.
Like
exactly.
this,
That's what I wanted to say. Yeah.
Okay.
Because this is what this is saying is that the element at the position Ij of matrix A
is equal to this. Yeah. This looks a little bit better. Okay.
Yeah, this
Cool.
is how I would have defined it if it was in the book.
Yeah, they
'Cause, yeah,
mess. Okay.
it's way more intuitive to look at this.
I think the rows and yeah, Haunted was like, I think they were just overthinking it with the rows and columns. Totally cool. It looks scary at first too, honestly. Makes more sense. Sick. We love sense. Good job, Haunted. You're very welcome, Haunted. It took a little bit for me to like understand the geometric series thing, but then I was like, aha, we just did that. All right, let's see. We got 2 questions left, and Hecker's got a physics question too. Okay, Hecker, you're coming up soon, Hecker.
How about I propose a problem
Okay,
in the queue?
propose a problem in the queue. Yes, we'll do it after Hecker's.
Yep.
Love it. Okay, let's see. DMs, what do you got? What do you got for me? Biology. People always ask me like, how do you tutor biology? I don't know. You just kind of just look shit up, honestly. At least at your level. When you get to the graduate level, you know, then you actually start doing, I think, cool things in biology, like how cells interact and genetics knock things out and stuff. And then there's predator prey. But right now, I don't know. This is all just like looking shit up. Which I don't really know how to tutor in it. It's just like, just write it down, maybe? Or just make some note cards? Founder effect. Oh. Bottleneck effect? Is this what Alabama is? Oh, no, sorry. Gene flow. Natural selection. Ooh, natural selection is cool. This is survival of the fittest. So, for instance, those with genes that are most well adapted for the situation and environment will procreate the most. So, effect on genetic variation. I don't know. You get like fitness maxing. A lot of people argue that we kind of got rid of natural selection because we're nice and we're humans and we don't let people with not good genes die. Which I agree, you know, we should be compassionate. But in nature, this is a natural form of evolution. It takes like millions of years to happen though, like thousands. So, effect on a population's overall fitness. It increases. That's what I would say. Sexual selection. When a species mates with each other because of a reason, like a certain trait or location, this is looks maxing for sure. This is a lot of and there's actually a really cool reason why this is not advantageous for survival sometimes. So yeah, I know it looks, yeah, sorry. I'm trying to think, like peacocks, for instance, right? Male versus female peacocks. So for instance, right? Yeah, these are males. So female peacocks are pretty boring. Look at this. They're not very, they're not mogging anyone, right? They're just kind of just boring ass birds. But the male birds have these impressive you know, plumes and whatever series of yeah, look, this is dope. Like, what? Peacocks are fucking awesome. Except they're super annoying, actually. Apparently they make lots of noise and they're very hard to kill and stuff. But being a peacock with bright colors and stuff like this is not advantageous for survival. It paints you as a bigger target, if anything, right? So it's kind of this weird thing where females are attracted to males that have, again, these impressive bright colors, these plumes and stuff. But in order to survive with those bright plumes and things, you become a bigger target. So I guess it kind of works in a way. You're selecting for who's able to survive but also is making themselves a massive target for everybody else. Yeah. It's interesting because in terms of natural selection, doing this as a peacock is not naturally selecting advantageously. Like, it's not advantageous to be bright and colorful and stick out. But I guess the females then look at it as, oh, if that guy can still survive and he's making a bunch of noise, then he must be a strong peacock or something. I don't know. So yeah, I don't know if your teacher would like that. Yeah, you should put looks maxing for here, because that's literally what sexual selection is. Like, all this, whatever, you know, clavicular shit where this dude's like, I don't know, beating his jaw with like metal and like doing meth. None of this is advantageous for natural selection. It's strictly for the vanity of looking cool. But natural selection would be, in today's society, finding people who, I don't know, make a lot of money. That's like natural selection. People who have health care. Or people who are good with children. People who are kind and compassionate, I guess, yeah. All these other things are kind of fun. Mutations, gene shuffling, genetic drift. Founder effect, this is where islands come into play, I think. So, for instance, yeah, certain populations of people that like live on islands, or even like Australia or like New Zealand and stuff, you get very strong genes that persist because there's no one really from the outside that's coming in to mess with the gene pool. Also, like, wacky animals can survive because the predators that would have usually eaten them don't exist. I think. Yeah. Okay. But yeah, if you want to know like actually how to do this one, you could probably just plug this into ChatGPT. That's how I would do it. Because I don't want to go look up all this stuff. Where is it? This chat. Here. Fill this out for me. Yeah, again, yeah. Work smarter, not harder. I don't know I mean, at least write this down. The fact of you writing it down will ingrain the knowledge into your head so that you can recall it. There is usefulness to being able to remember information like this, for sure. Because it builds up a knowledge base that you can then select on and like recall when you see other things that are related to it. So again, you may ask, why are we even doing this? Because we could just ChatGPT and hit print, but you wouldn't learn it because you wouldn't be reading anything. You should use this so that you don't have to keep going to search for things, but you should be writing it in your sheet, because by doing that, you're committing it to memory. And then that information is in your head. And that's what we call like the schema of life. Like, you have background knowledge that you can recall when you need to solve new things. Yeah, and my brain is already decently good for memory, so that'd be good. Yeah, exactly, yeah. So the reason why they make you do this, I know it seems pointless, is because they just want to build up your like background knowledge of facts so that when you see things you don't understand or things that are new, you can relate to the old things. And by using ChatGPT, you can apply a selection pressure for polar bears that can swim better. Yes. The poor bears, the poor polar bears are losing their ice caps because of chat. Yeah. So yeah, actually, in fact, yeah, by using ChatGPT here, Blue, you are also helping towards the natural selection and genetic improvement of polar bears or Arctic things, or yeah. Let me see what it said for like sexual selection. Yeah, can increase or decrease variation. Sure. May increase reproductive success, but sometimes reduce survival, right? That's what I was talking about, right? With the peacocks. So, for instance, if you're a bright motherfucking peacock, maybe like a lot of girls want to sleep with you. Great. That increases reproductive success. But also now you become a huge target for other things that want to eat you. So that can reduce survival. Or, yeah, in the case of clavicular, I'm sure by smashing his face with things and doing all these weird peptides and shit, he's probably improving his reproductive success, or not.
You done messed up, Aaron!
But he's definitely reducing his survival. So, yeah. Looks maxing isn't all it, you know? It depends what you value in life. I think survival's a great thing, so. Helping natural selection by killing stuff. Yeah. I mean, it's a cruel truth or reality, unfortunate truth of the world. Coolest dude said, I just got marks back for a test of a really subjective subject. I got A-, 1 out of 3 out of 100. Wait, you got a 33 out of 100? That's not good. What was the class in? Coolest dude. I hope it's not the one I helped you study in. Alright, there we go. Let's have a Hecker next. But here, I'll post also the ChatGPT link for you. Blue, so you don't have to like look all this stuff up again. English. Yeah. Very much a subjective course. Yeah, I got you, dude. Here, let me just copy the link for you. There you go. So you can go access it. Don't let that get you down, by the way, coolest dude. I remember when I was in high school, my English teacher just used to shit on me like all the time. Just be like, you can't write. Would always give me like bad grades for my essays and stuff. This was for like AP. I want to say it was AP Lang, not AP Literature. And, you know, she's like, you're not going to get anything more than a 3. Like, your writing sucks. I just always got bad grades. And then I took the AP exam and I got a 5. I was like, fuck, what? So, yeah. It's a subjective class. If your teacher just hates you and just wants to give you bad grades, it's not your fault. Well, maybe it is your fault why they hate you, but you're not bad at writing. You don't deserve the bad grades. All right, Hecker, let's see. Block A with mass 4 kilograms sits on top of a table where mu is that and mu k is that. Block B with mass 6 grams hangs from a massless blah, blah, blah. What is the acceleration of block A? What is the tension in the rope? Great. First thing is force diagrams. You have a question? What's up? I also, whenever I see this, I like to think about, why do they do FG minus FT? Yeah, I'll explain it to you. So we're going to describe the overall motion of the system because they're connected by a rope. I'm going to talk about this. I'm going to say, like, overall things move in this direction, right? So I'm going to call this plus, and I'm going to call this minus. So when looking at motion of this in the X direction, okay, when stuff's doing this, I'm going to call to the right as being positive, and to the left as being negative. When I look at object B... Oh, Norowski, nice. You got it written up. Okay, sweet. Things going down is positive, and things going up is negative. This is the key thing. You have to think about the overall motion of the system and define a direction for plus and minus, and then they're connected. Because motion in the Y direction here corresponds to motion in the X direction here. So, yeah, in this case, yeah, you have FG pointing down, and you have T pointing up. And then for A, you're going to have T pointing to the right, and then you're going to have, like, probably some sort of friction pointing to the left, right? And then you also have force gravity A and then normal force, right? And then the key thing here, right, is that motion in the Y direction here, which again, let's remember we described down as plus and up as negative. This is going to be MBG, which is FG minus T. Yeah, it's okay, it happens. So, and then this is going to equal to MBA. corresponds to this motion in the x direction, which here, right, we described this as plus, this is minus in the x direction. So we're going to say that T minus Fs is equal to ma times a. And then that acceleration this way is equal to acceleration this way. So these a's are the same. Now, what they probably want you to figure out first, right, is does it move, right? And so in order for this to move, you need the tension here to break what like Fs max would be. And then here we can write stuff in the y direction real quick. So here you just have Fna is equal to Fga. And Fga, right, is just like ma times g. So you have T minus mu whatever ma g is equal to ma times a. And I think what we do here is, yeah, okay. You can solve for the tension here. Find the acceleration. Yeah. So here's what you do. Do we want to assume it's moving? Because you could do this. This is physics, Cody. So what you would say is that if it's staying still, then acceleration would be equal to 0. So tension would be equal, in this case, right? If acceleration was 0, tension would be equal to mb times g. And then here, right, T minus mu mag would also have to be equal to 0, right? And let's see if that's possible, right? So you can plug that in, right? And so you say, okay, cool. So mbg minus mu mag is equal to 0. And we can actually just solve for mu here, actually. So you get mu is equal to mb over ma. Right? Because the g's will cancel. So this is the minimum mu s to stick. And what was MB? MB was 6. MA was 4. Oh, so you get 6 over 4. So yeah, no. Having a mu s of anything over 1 is like impossible. So it doesn't stick. It's actually kind of cool. Why did I do MB minus MA? Okay, so looking at this equation. So this is the X equation for block A. You have tension minus mu mag equals MAA. And then what I said is, okay, but if this thing is stuck, right? If acceleration is 0, then the tension in the rope has to equal mbg. So now I plugged this into the tension here. And so that got mbg minus mu mag equals 0. I cancel the g's. And then I can solve for mu to get this. So that's what mu needs to be in order for acceleration to be 0. And in order for the thing to stay stuck. And you can see, like, it's just not really possible. Actually, in fact, like, anytime the block hanging is heavier than the block on the top, it's just not going to work. So if block A was the one with force, that would be positive. What do you mean with force? Sorry. Block A was the one with force. Oh, Gravity. Yes, but the issue is that like gravity on block A would only point down. So it doesn't help. If there was something here, right? If there was a pulling force or something to the left as well, then this might work, right? And then you could figure out like, oh, what does FP have to be? Yeah, gravity doesn't help this out. I mean, it does provide some of the friction, but yeah. Okay. So we've shown that A is not 0. So A does not equal 0. So then you go back to the drawing board. And you say, okay, cool. Well, I still have this. And then I still have this. And then from these two equations, you can solve for A, because you can just add them up to each other, I think. Right? Is that what we want? What is the acceleration? Then we want the tension. Okay. So let's call this equation 1. Let's call this equation 2. What's up, Raven?
My man.
If I do equation 1 plus equation 2, watch what happens. It's kind of cool. Okay, why massive in NBA? Okay, cool. Because the sum of forces, Hecker, in the y direction, which is FG, MBG, minus FT, that has to equal MA, right? Sum of forces equals mass times acceleration. And since we're talking about block B, that's the mass of B times acceleration. And then A is acceleration. Does that make sense? But wouldn't block A, it does. It does. And that happens through the tension, right? Because the tension in the rope is equal to the mass times acceleration of block A plus the friction. And the more tension there is, the less acceleration there is. So this is the block on the top. So as you have more friction, you end up having more tension to give you the same amount of acceleration. And then having more tension will create slower motion. They're connected. The tension is what ties together the friction with the motion of the other one. You get it? Okay, cool. So when you add these, the cool thing here is that this is plus T, this is minus T. That goes away. Okay, and now I'm just left with MBG minus mu MAG is equal to MA plus MB all times A. You see how, because this is the same A, right? So I can group that together, like factor it, and then finally I get, okay, well, acceleration is equal to MBG minus mu MAG all over MA plus MB. Which, what were all the mu's? Yeah, so mu connect 0.21 and it's 4 and 6. Okay. So you have 6. So first of all, you can pull the G out, right? So you have G, and then that's going to be 6 minus 0.21 times 4 all over 10. Let's see what we get from that. So 6 minus 0.21. Wait, is that mu? Is that mu MAG? Yes. This is mu. Then this is the mass of block A, and then this is times G. So what I did is I pulled the G out. So now it's just this kinetic friction, right? This is mu K times MA. Yeah, you're good. Yeah, always ask questions along the way. It's good. Okay, so that's that, and then you do times 9.8 divided by 10. You could have just said G equals 10 and whatever. It would have been the same thing. So you get
because it's nicer.
A equals G equals 10 is actually quite nice. No, but whatever. I'm a 9.8 enjoyer. Okay, there you go. 5.05 meters per second squared, which I think is what Narosky got. What'd you get?
I took G to be 10.
You took the G equals 10.
Oh shit, surprise, motherfucker.
Okay, 5.16. That's fine. And then from this, you can then solve for T, just using either one of these equations. So, I don't know. We could use this one, for instance. So then, 6 times 9.8 minus T is equal to 6 times 5.05, right? Solve for T.
Should be
And
28.5.
yeah, right, because it's just 6 times 4 is like 24, right? Here, you can just do 9.8 minus 5.05 times 6. Yeah, cool.
Yo, I got down with that.
28.5. Look at that, dude. It's actually really nice. Wait, how does that become such a nice number? The fuck? It's actually really cool. Okay, yeah, 28.5 newtons. And there you go. There you're done.
Well done! Well done!
One quick question. All good. What's up? Can you go down, please? Yeah, sure. Why did you use block B mass in 6 times 5.05? Okay, sure. Because when using this equation, right, which was the equation, the force diagram for block B, this was mg for block B minus T was equal to ma for block B. And then block B was always 6. Use block A in the exam? Well, okay, you could have used this one, for instance, but then you would have had to plug in mu, and you would have had to plug in MA, and then G. It's just more stuff.
Not good.
It's the same thing. You could have also done it with this equation. It's just like more things to do. Yeah, just plug it in. You can plug it into this one or this one. Doesn't matter. It's a pretty standard question, though. Oh, you didn't? Uh-oh. Oh no.
Oh no!
It's okay, Hecker.
Oh no!
The important thing is that you're learning now.
No!
We all make mistakes. But yeah, okay, great, awesome, cool. Yes. I guarantee this will come up again in your life at some point, so as long as you understand it now, don't worry about like fucking it up beforehand.
Well done!
All good. Okay, Narosky, last 10 minutes. Give me some pain. What do we got? What do we got?
Let's get it.
Which one do I want? Do I want the first?
Both.
Oh, you think I can go? Okay. Ooh. Oh, this is the
okay, so
this is the math team,
this
right?
is
You're
argument.
your math
Yeah.
team did very well or something, right?
Yeah, my buddies did this. I didn't participate, but they went and they got like great prizes.
Wow. Okay.
Yeah, my best friend, actually, this guy is actually better than me at math.
No way.
No.
That doesn't exist.
Yeah.
Okay.
He got the grand prize, which means like across all grades, like 9 through 12, he got the biggest amount of points.
Uh-huh. The super gold
So
medal.
so he got gold. Yeah, super gold medal.
Super gold plus. Cool.
Yeah.
Which one which
So-
one should we try to do?
The first one is pretty difficult. Well, it's not difficult. It's just long.
Okay. Maybe one that's not long,
Um,
but at least elegant.
I'd suggest the third one.
Okay, let's do it. I'm gonna translate this. Because I don't speak.
I can translate it for you because it's yeah.
It's not that bad. Okay.
It's very it also has very few words, so
Okay.
yeah.
I'm gonna assume this means for a matrix AB that is a
Yeah.
2x2 matrix, right?
Yeah, with
Whatever
with
the fuck
complex,
this word is.
yeah.
What does it say?
Show
Arati?
that.
Arati sha.
Aratazzi.
Aratatsi. Okay. Show that. AB squared is equal. Okay. So AB squared is equal to negative A B squared A. I don't know what this word means.
If and only if.
Okay. If and only if. BA squared equals minus B A squared B. You know I love these ones. These ones are so fun.
Yeah.
Okay.
I know you like these, and that's why I suggested it.
Oh, I do like these, yeah. Because I think to expand this, right? I would want to say like, oh, AB, right? Equals negative A, B squared A. Yeah?
Yeah, I didn't solve these, so this is the first time I'm gonna do this.
Oh, this is the first time you're seeing it too. Ooh, we're going to learn together.
Good job.
Okay, cool. Let me think. Okay, this is the same thing as negative A, B, B, A. So, like, how can I make this look like this, I think? ABBA all up in here. Oh, okay. Wait.
So you can move ABBA to the other side and factor out AB.
I see. Oh, I see. Okay, I think I see what you're saying.
Yeah.
All right. No.
That's my first.
So
instinct.
you would move this over to here.
Yeah, and factor AB out.
All right, let's do it. All right, let's go that way. So then we have this plus this is equal to 0. And so for those of you watching, you have to be careful with matrices. I know in regular math, like 3 times 4 is equal to the same thing as 4 times 3. That's cool. But it's not necessarily true in matrices. Yeah. Matrix A times matrix B doesn't always equal matrix B times matrix A. So that's why we have to be very careful about the order of things. For instance, if I multiply this side by B, I can't just multiply this times B. I have to do B times this as well. I join back and I see Okay. So, but Narosky brings up a good point here. You can use the distributive property, I guess, because this is the same thing as AB times AB, and this is AB times BA. So let's factor both of these things out. So AB times AB plus BA is equal to 0. Fascinating. And then let's see. I'm trying to see and we say if B. Let me expand this out maybe. And maybe it'll illuminate something for me. BA is equal to negative BAAB. Baba equals Bob. I fucking love this shit. Okay. Okay, so this tells me either AB equals 0 or AB equals minus BA, right?
Yep.
And I don't think AB can equal 0, or because that's not a matrix, right? Because that means matrix A or matrix B would just be 0.
Oh yeah.
Yeah. So I don't think that's allowed. So we can't do that. But this is true. Okay. So if AB equals minus, oh, I already see how this is going to work. Because remember, what are we trying to prove? We're trying to prove that Baba equals negative Bob. Oh, this is super cool, actually. Okay. This is where the order matters. I'm gonna act
So
B on both sides from the left, right?
we can like if I may speak for a bit.
Yeah, please speak.
We can rigorously prove that AB cannot be 0 because if you take determinants on both sides, you'd have that determinant of AB plus BA is 0.
Okay.
Otherwise, if AB is 0, the determinant of AB plus BA is the determinant of BA, which is 0, which is a contradiction.
Oh. I see what you're saying.
Do you see it?
Yeah. Sorry.
Yeah.
So you're saying if this is equal to 0, then the determinant of this is also equal to 0? Wait. Say that again, sorry.
The determinant of the so if AB is 0,
Yes.
then
Determinant.
the determinant of AB plus BA
Yeah.
is the determinant of BA.
Okay, because this is 0.
Yeah, which is 0. Yeah, which is 0.
Oh, and then that's a contradiction. Why is it a contradiction that the determinant of AB plus BA is equal to the determinant of BA?
Because we're supposing that it isn't 0. Because if it is 0,
If it is 0, yes.
hold on, how do I say this?
Yeah, I'm curious here.
It should be a contradiction. Like we shouldn't be allowed to have AB equals 0.
I agree we
This is
shouldn't
what I'm
allow...
thinking.
I agree that AB should not be equal to 0, but I'm curious about this. Because if AB is 0, isn't the determinant of nothing plus something equal to like the determinant of the something? Isn't that true?
Yeah, I think that's it. Yeah, I think that's it. Yeah.
Yeah. Okay. All right. So from here, let me think. What am I trying to get to? I'm trying to get to Baba. Okay. I'm gonna act. I'm gonna have them both act on an A. Okay. That's okay. Oh fuck! I'm gonna get Abab. No. Damn it. Oh shit. AB equals minus BA. No. Wait. Because if they both act on the right on an A, you get that. And then if they act from the left with a B, you get this. But that's not what I want. Right? Fuck. AB squared, AB equals negative AB squared A. Cool. Negative A, BBA is ab. Okay, move that over. Ab. And then I pulled out the ab, so I got ab, BA. No. Yeah, no, that's cool. AB equals minus BA.
So what I'm noticing as well
Yeah.
is since it's symmetric, like replacing A with B and B with A, it's symmetric.
Mm-hmm.
We have
Me from here?
a question that asks us. No. Like in the question, it says if and only if. That implies we'd have to do two cases. So the necessary and the sufficient case.
Got you.
Right.
Right.
But since it's symmetric, just an implication is sufficient.
Okay.
So if we prove if A proves B, then we don't need to show that B proves A, because it's symmetric.
Got you.
Okay. I just wanted to point that out.
Yes.
Oh, okay. I see. Yeah.
What do you see?
I think we take trace of both sides.
Of trace of both these sides or trace of both these sides?
No, a trace of both sides on like the initial equation.
Oh, you
Like
think way over here?
AB squared is equal. Yeah.
Oh. See, I wanted this to turn out to be something nice like this, but I guess not. Okay, fine. Okay. So you're saying the trace of AB squared or AB, well, fuck. Okay. What does that pull out? What's special about that?
So the trace has a property that if you take the trace of AB, it's the same thing as taking the trace of BA. You can essentially move around the matrices inside the trace.
Okay. I didn't know this, but okay.
So instead of writing it as AB squared A, you can just write it as A squared B squared. So minus A squared B squared.
Okay.
Yeah, and you can pull the minus up as well, because minus the trace is the trace of the minus.
So is equal to negative trace. And then we can just say A squared B squared, which is the same thing as... What's up, Fembox?
Oh, yeah.
Which, what? This is also equal to the negative trace of AB squared, no? Which is also BA squared?
Yeah. So the trace of A squared B squared, so then... Yeah, it is AB plus BA squared.
Mm-hmm.
Wait. So then, yeah, the trace of AB plus BA squared. Oh, I see.
What's up, Joseph? Do I remember you? There are a lot of people that come through, Joseph. Oh, shit. I gotta go. I actually gotta go teach someone else. Sorry. I didn't notice the clock ran out.
Oh, damn.
Okay, this is a fun one. Maybe let's attempt this on Friday during
Yeah, this I'm gonna write this down and I'm gonna find a nice solution for this.
All right, cool. We'll do it. I appreciated this. I had hope that I was on the right path here, and then I was disappointed in myself. Anyways, okay, cool. Let's close out the stream. All right, thank you. Oh, what's up, Teacup? Good to see you, dude. Thank you, everyone, for coming to Actual Education Office Hours. Appreciate all the questions we had today. You guys are awesome. Please come on by tomorrow's stream at 4 o'clock. Narosky's going to be teaching us some cool, elegant competition math and elegant strategies. Joseph, let me know how JEE went. Femfox is in Australia. Wow. I still haven't been to Australia. I need to go at some point. But yes, if you found us on TikTok or YouTube, make sure go to the website actualofficehours.com. Yeah, Narosky. Yeah, people are looking forward to you tomorrow, Narosky. Yeah, so no pressure. But if you click here on streaming schedule, you'll see the schedule of all the awesome streams that are happening. So we actually have a lot of stuff happening. Right. Tomorrow, looks like MathPond is doing probability and random processes in the morning. We're going to be doing a fun stream with Narosky at 4 o'clock, and then we're going to be playing chess. We're going to do a chess tournament Friday after Narosky in the evening. And then Saturday, jam-packed with more things. Zach is going to be doing math and science help in the morning. We're going to be doing a golden hour podcast with Ramton going over proofs. And then it looks like MathPond is attempting a 24-hour stream. Best of luck to him. That's intense. And I think he just started streaming this week. But okay, I'm props to him if he wants to try it. I didn't try a 24-hour stream until I've been streaming for like 6 years, and it's rough. I had times where I was hallucinating for sure. So we'll see. Best of luck. But yes, lots of fun stuff. So make sure you go check that out, and also go join our Discord, because all the questions we do, we post the answers in there. All right. If you're watching us on Twitch, we're gonna go raid somebody. Awesome. So let's go see who's also streaming these days. What do we got? Chill yapping stream. Let me show my boobs. Yeah, great. Okay. Where is math and science? Okay, cool. Nerduino's on. What's up? Shark Geeks. Dude, there's so many people actually streaming today. This is great. Pen's playing Zelda. Super fun. Let me send you to someone doing some science stuff. Let's send you to Nerduino. Live astrophotography, or he says be right back. Okay, he's not on right now. Okay, let me go raid somebody else. Insect slaying. Everyone's got so much fun stuff going on. Okay, scuba gear repair. This looks cool. Okay, go check out Shark Geek. I met him at TwitchCon. He's a great guy. I think he makes songs about sharks. Okay. All right. Enjoy the rest of your Thursday. We will see you Friday for jam-packed streams and lots of fun over the weekend. So come on by. Peace.
Yeah, they're really bad. But that's the whole thing.
Peace, Narosky.
That's the whole picture.
I'll see you tomorrow.
Peace.
So anyway, though, we've got... I can't say enough good things about MLJ, man. I'm so glad here. Whoa, what is it? What is this? Everybody's raiding out for the night, huh? We're approaching 11, so everybody's like, let's go drop in on this shark nerd. Actual education, what's up? How you doing? What up? How was your stream? What were you educating this evening? Tonight we are talking about situational awareness and awareness of ecosystems that you are about to be spending in time in. Specifically, how the 4 attacks in Sydney, Australia that